Hello. In this video, we're going to go over what seafloor spreading is, which is one of the major processes in plate tectonics. And this is the activity that you will be doing in your weekly work. And so we will answer all these questions, and then at the end, you will explain why continents are moving using the following word bank. So let's get started on this. This is an animation of seafloor spreading, which is one of the major processes in plate tectonics. So where does seafloor spreading take place? Well, this is the mid-ocean ridge. It is the shallowest place in the ocean, or one of the oceans. And you can see that magma is coming up and pushing through and forming new seafloor right here. And the reason it's able to push up there, as I've said before, is that you have two plates that are being pulled. One plate is being pulled this way, and the other plate is being pulled that way, and as they are pulled apart, magma is allowed to seep up because there is a zone there that is very thin and it just pushes through. So where is the new ocean floor coming from? It is coming from inside of the earth, and the magma is coming up, and as it reaches their surface, it is called lava, and it hardens into a basaltic rock. And what type of floor is this? This is oceanic floor. So wherever you have seafloor spreading, you have new ocean floor being laid down. Even if it's on a continent, and there is a place on the world, those two places. One is Iceland, and in Iceland is actually being pulled apart, and as it's pulled apart, new ocean floor is being created right there. And so it will eventually be two islands instead of one. And the mid-ocean ridges are the shallowest spot on the ocean floor, as I've mentioned before. And the seafloor spreading is creating two plates. So you have one plate over here, and you have the other plate over here. And they are moving apart from each other at 5 centimeters per year. All right, so the next thing is, what are transform boundaries? Well, transform boundaries I can actually show you. So transform boundaries are boundaries where two plates are sliding past each other. So if I have another mid-ocean ridge here, this is creating where these two are sliding past each other. That is a transform boundary. It is also a fracture zone. And so we have a transform boundary which forms fracture zones where the two plates are sliding past each other. So here we have them sliding at different rates, and so this is a fracture zone where you have some minor earthquakes all over. Same thing here, you have minor earthquakes fracturing all over at this transform boundary right here. So evidence for seafloor spreading. So one of the big pieces of evidence that the seafloor is spreading part is called paleomagnetic evidence. And so what happens is that the earth has magnetic field, right, a north and a south side where the magnetic lines of force move around. And so rocks that are created at the mid-ocean ridge actually align with this magnetic field, right? Well, right now they'd be aligned with the north side up and the south side down in a magnetic orientation. Okay, well, about every 2,000 years, these field lines change. And when they change, the rocks have a different magnetic orientation. And so here you have our strip of rocks that had south-north. Now they have north-south. Now they switch again, and we have south-north, and then north-south. So we have on the bottom of the ocean floor these bands of rock with different magnetic orientations in about 2,000 year intervals, showing us that the sea floor is actually being created at the middle and then being pushed away, right? And again, what is happening is not really being pushed away. We have sea floor that's being pulled this way, and we have sea floor that's being pulled this way. And so it's pulling apart, and so magma is allowed to come up, and that magma then cools and turns into basalt, which then, like a conveyor belt, is pushed away. Second piece of evidence for seafloor spreading is the crustal age of the rock. So we actually have dated the age of rock across the ocean floor. So what we have here is, let me orient you, we have North America, which is the United States, and Canada, Mexico, Latin America, South America, Africa, Europe, Asia. So this is the Atlantic Ocean, and here is the mid-ocean ridge, and we have actually aged the rock, and you can see from this graph that the age of the rock closest to the ridge is really young, all right, which is our oranges and reds. And then as you move farther away from the rock, it gets, or from the ridge, it gets older. All right, so we have here, this is off the coast of South America, right? So we have really young rock, and as it moves away, it gets older, and as it moves away, it gets older, and we have our oldest rock, the farthest from that, which is over here. All right, so this is evidence that the seafloor is actually forming at the mid-ocean ridges and moving apart. The third piece of evidence for seafloor spreading is sediment thickness. So if we look at the sediment thickness across the ocean, so again we have North America, we have South America, Africa, Europe. Here is the mid-ocean ridge right here. If we look at how much sediment has accumulated on the ocean floor, it's evidence. So right at the mid-ocean ridge, where we have sediment is being laid down, but it's being laid down only recently because it's only new seafloor, we have very shallow thickness. It's not very thick at all because the seafloor is just being created. But as you move away from that ridge, you can see that more and more sediment is accumulated. So the farthest from the ridge, we have the most sediment accumulation from that ridge. All right, so we have our ridge here, okay, and again, no sediment accumulation. Now right here we actually have a subduction zone where the plate is being destroyed, and so at that plate boundary there's a trench, and the sediment is very shallow there because sediment is going into the trench and being destroyed. All right, so those are the three pieces of evidence for sea floor spreading. We have the paleomagnetic evidence, we have the thickness in meters of sediment, where the most sediment is farthest away, accumulating on the top of the floor, and we have the age of the ocean rocks, where the youngest rocks are formed at the rift and the oldest rocks are farthest away from the rift. Now we're down to our final question, which is explain why the continents are moving. Use all the words in the word bank. So let's go ahead and review what we've talked about. So this is an animation of plate tectonics. And so what we first need to look at is what are the plates. So here's our plates right here. And again, a plate is just the upper mantle and the crust. And so what we have is we have the upper mantle that is being pulled away, and we have either ocean on it or we have continents on it. All right, it's about 100 kilometers thick. So if we can actually name these, we have continental crust that is on this plate and it's being pushed, and we have oceanic crust that is being formed at the ridges and being pushed away. We have our magnetic lines of evidence that are showing that the plates are being formed and pushed out. So we have plate boundaries. So we have a plate boundary here. So seafloor spreading is taking place right here. And as the magma is flowing underneath, it is pulling this plate away. And we have a subduction zone right here, which is another plate boundary. So again, we have plate boundary here, plate boundary here. So seafloor is being created here and it is being destroyed here. We have lava coming up right at this point at the seafloor spreading. And as it comes up, it turns into basalt. And this is a continuous process that keeps on going on. And we have our continental crust that is less dense, and so it is not being destroyed. And we have our oceanic crust that is more dense, and it is always subducted and being pushed under. All right. And over here we have the same thing. We have our oceanic crust being formed, and it has a continent being pushed away on it. The continent is less dense, and we have our seafloor coming in. It's more dense and it's being subducted. So that is our quick thing on seafloor spreading. If you have any further questions, please see your science teacher.